Welcome back. It's time to talk a little bit about materials. The drone that we've imported did not have a material. And once we imported the FBX the first time, Unreal Engine generated a new asset for us, which it called a material, and it prefixed it with an M for material, and it's called mDrone. And we saw that our drone has this material automatically applied to it. If we open up the drone in the static mesh editor, we see under material slots that mDrone is applied. Now, these material assets can be edited and customized within the Unreal Engine editor. And we're going to take a look at what those material assets look like by opening mDrone. Let's go ahead and double click on that. And this is what the material editor looks like. Like many editors in Unreal Engine, it has a graph. This is called the material graph. We can right click and move around in the material graph. We can scroll out and scroll in to zoom out and in. And we have one big node. These blocks in our graphs in Unreal Engine are called nodes. The node that has the same name as the material asset itself, we call this the result node. Whatever we have plugged in to the input pins in this node determine what the material looks like. And the material editor has its own little viewport here with a sample mesh that has this material applied to it. We can left click to rotate around the material, and in the viewport, there's even a light shining on one side of this sample mesh to show us what it looks like when light hits and bounces off of the object that has the material applied. Now, the 5 icons at the bottom right of this tiny little viewport allow us to change whatever mesh we have assigned as the preview mesh in this viewport. The first one is a cylinder, so we can see what the material looks like on a cylinder mesh. We can apply this to a plane and see what that looks like. It's transparent from the back, but we can see the front. We can assign this to a cube, see what it looks like on that. And the last one allows us to choose a mesh and set that for previewing the mesh. Now, the way to do that is to open the content drawer and select a mesh asset from within the content drawer. Once we click on it, it's selected. And if we come back to the material editor and click on that last icon, well, now we have a static mesh that we chose, and the material is applied to that. Now, the result node for the material has a number of input pins, and these all affect what the material looks like. And the most basic is called base color. Base color is simply color information and nothing else. And what do we have hooked up to base color? Well, we have this, another node. It has a name, it's called param. Of course, these nodes can have their names changed. We can select it, and like most things in the engine, we have a details panel that populates with details about this node. And there's a parameter name. It's called param. We can change it to base color if we like. And now we see that it has that name. Now, base color is what we call a vector. A vector is a collection of numbers, so it has multiple values. And that's because in computer graphics, a color is actually a combination of 3 colors, red, green, and blue. You can change the proportions of red, green, and blue for any color to change what that color looks like. If we double-click on the base color node, we're presented with a color picker. And this allows us to change the proportions of red, green, and blue to get a different color. Now, notice that this vector doesn't just have 3 values, red, green, and blue. It also has a 4th value called alpha. And for the base color, for our result node, the alpha isn't taken into account, but other types of inputs can take alpha into account, and lowering the alpha is going to lower how much you can see of the material for those specific input pins. So clicking and dragging around in this color wheel is going to change the relative values of red, green, and blue, and also the hue, saturation, and value. That's what the HSV is for. Now, the 2 ribbons next to the color wheel adjust these properties. The first one, hovering over the little arrow, says saturation. And we could change the saturation. Notice this is actually changing the values for red, green, and blue. and changing our little dot on the color wheel as well. It's just going to go from desaturated, which is completely white, to fully saturated. Next to that, we have the value, and this goes from the full color to a darker color. And all the way down, we have a value of black. Now the H value, the hue, is going to move us left and right along this color ribbon, which starts at red and ends all the way over here, just past violet, fading back into red. So we can drag that left and right, and notice we're going around the color wheel to the extremes of the different colors. So that's how the color picker works. And once we've chosen a color and we click OK, we can see that color represented in base color. Now I left it at this magenta color. That's probably not the best color to leave it at, so I'm going to bring it up to a nice blue. In some game engines, that magenta color is indicative of the absence of a material, so we'll stay away from that magenta color for now. So that's changing the base color for our material. Now I'm going to click on the drone tab and dock it next to our basic map and go back to our basic map. Now these drones don't seem to reflect that material change, do they? Well, that's because even though we made changes to the material, we did not save the material, and we won't see those changes until we do so. Now, saving a material can take a long time because materials can be quite intensive, as there's a lot of information often in materials. So while we could save the material, in fact, I'll do so now by clicking on the save icon. This material is quite simple, so it didn't take too long. If we go back to basic map, now we see that blue material. But in the future, as materials start to get more complex, that saving process can take some time, and you may not want to save those changes just yet. You may just want to see what they look like on the mesh. So let's make another change. Let's double click that base color and change it to a different color. We'll click OK. And instead of saving this time, I'm going to click on Apply. This will apply any changes to the original material and use it in the world, but we won't actually save those changes. So as we're working, let's say we make a change we don't want to save. Well, we don't have to save it to see what it looks like in the world. We can simply click on Apply and then go back to our map and see what it looks like. So now we know about base color. But what do these other inputs do? Well, you can always hover over them and get the tooltip, and usually this gives you an idea for what they do, but we're going to get some hands-on and see what they do. I'd like to change my preview mesh here back to a sphere. Now, I can't see it because I'm inside the sphere. I'm going to right-click and drag out. I don't actually have to hold Alt to do that in the material viewport because we don't have the ability to move around. We can only rotate and zoom in and out. So left and right clicking is all you need in the material editor. Now, it's a sphere, and I'd also like to see what this material looks like on a sphere in our map. So I'm going to find a sphere and I'm going to drag it into my level. I'm going to go to my content browser. And because we have starter content, there are some shapes that we can use. In the starter content folder, I'm going to double click on shapes. And here we have a number of basic shapes that we can work with. And I'm going to use shape sphere. I'm going to drag that on into my world, and now I have a sphere. Now I'd like to use that M drone material on my sphere, but I don't want to change the material for the static mesh asset. That would mean every time I drag in a new sphere, it would have that material assigned to it. If that's what I wanted, I could double click on shape sphere and change its material here. But I don't want to do that. I only want to change the material for the sphere that I dragged in. We call this an instance of the sphere. Well, luckily we can do that because we have a details panel. If I look in the details panel, notice that the details panel has some properties here. If we scroll down, we have the materials section, and this is the material that's assigned to this mesh. I can open the dropdown and I can search for M_drone, and I can change this to M_drone. And now the sphere has the drone material applied. So I didn't have to go and change the asset file, the U asset called shapesphere. I could change the individual instance of the sphere that's in my level. And that's very useful, and you may do this from time to time. So we now have our base color changed. I actually really don't like this yellow, so I'm going to put it back to a nice blue color. And we're going to talk about the next input pin in the result node. Now these nodes can be clicked and dragged around. I can take this base color and move it off to the side. And that wire is connected to base color. And as long as that wire is connected, the result node will get that data. Now metallic is what it sounds like, controls how metal-like your surface looks like. Now I can drag a value into the metallic to change the metallic property. Now how do I do that? Well, metallic can be a value from 0 to 1, and I can get a node for a single value, not a vector like the base color, which has 4 values, red, green, blue, and alpha, and of course the top pin is all 4 of those packaged up into one vector. I can get one single value. How do we get a node for that? Well, to the right we have a palette. If we click on it, we can expand it. And we can get different types of nodes from here. We can even search for them. If I search for constant, we have several options for constants. We can just have a regular plain old constant. We can get a constant 2 vector, which is like our base color vector, except it only has 2 values instead of 4. We can get a 3 vector and a 4 vector. This base color is a 4 vector. Now a constant is an integer value. It's just a whole number. And if I click on this and drag it in, now we have a node that returns a single value. You can click and drag off of the output pin to get a wire, and you can hook this wire up into one of these nodes. I'm going to hook it up into the metallic node. Now you can see that it has a value with the text box. The text box can be changed. If I change this to 1 and hit enter, we have now entered a value of 1 for metallic, and as you can see, our object looks more metallic. Metallic is a value between 0 and 1. If we increase this value to, say, 10, we're not going to see any more metallicness because 1 is the highest the metallic value can be. But if we change this back to 0, we'll see that the sphere looks much more flat. Let's put that to a value of 1, and let's click on Apply. And then we can go back to our basic map and see what that looks like. It looks a little bit more metallic. So that's what the metallic input pin on the result node does. So I'm going to click and drag this 1 node. So it's up here and out of the way. So we can take a look at the next one, which is specular. The pop-up says use to scale the current amount of specularity on non-metallic surfaces and is a value between 0 and 1, default at 0.5. Now, the keyword here is non-metallic. So I'm going to take that value of 1 and change it back to 0, so we have a non-metallic surface. A metallic value of 0 is non-metallic. And I'm going to get a constant that I can plug into specular. Now, I don't have to open the palette and click and drag out constant. Notice there's a hotkey here that says 1, and the way to use that hotkey is to hold the 1 key down on the keyboard and left click. And that's going to give me a new constant. So let's hook up this new 0 value into specular, and we'll see what it looks like with a 0 specular. And we can change this value to change the specularity of our material. First of all, though, let's apply and look in the world. We'll see that it looks nice and flat, but we can change that value to, let's say, 1 and click apply. And now we can see in the world that it's more shiny. So specularity makes it look shinier for non-metallic surfaces. Now we can still change this to 1, but now that specular isn't going to do anything. We can change it back to 0. We still see the same thing because metallic surfaces don't use that specular. Let's change the metallic back to 0, and let's take a look at the next one, which is roughness. The pop-up says controls how rough the material is. Roughness of 0, smooth, is a mirror reflection, and 1, rough, is a completely matte or diffuse. So I'm going to get another scalar value. Now, I don't have to hold 1 and click to get a new one. I can duplicate one of these. Now, duplicating a node in any of the graphs in Unreal Engine is done by one of 2 ways. We can Control-C to copy, Control-V to paste. That's one way. I'm going to hit delete on that one. Or we can select a node and Control-D, and that's going to shortcut the Control-C, Control-V process. It's going to duplicate that node. Now, our roughness has a value of 0. That should be really smooth, like a mirror. But it doesn't look like it. It's pretty flat, isn't it? Well, that's because our specular is all the way down. So in order for a low roughness to give us some shininess on our material, our specular has to go up a little bit. If we change it to 0.5, notice we're nice and shiny. We can even see reflections. And with a specular value of 1, now we're really shiny. Why don't we go ahead and click Apply and look at our material here in the editor. We can see that it's nice and shiny. It looks like a marble or a glass ball of some kind. So we can change the values of specular and roughness to get the look that we want on a given surface. I can change that roughness to 0.5, and it's not nearly as reflective anymore. 0.2 is a little bit more shiny, but it's kind of blurry, right? It's less rough, but there's still a little bit of roughness. We can't quite see those reflections that well. A value of 0.1 makes those reflections more clear, and a value of 0 is a mirror finish. Now, we're not going to go over all of these inputs for the result node. We're going to get a feel for more of them later on in the course, but I'm going to jump ahead to normal. Now, normal is not something that we're going to put a single value in. We're not going to use a constant 1 value. A normal takes in a map. A normal map for a given mesh contains color information that tells the engine how to bounce the light off of the surface of the mesh. Now, to see how a normal map works, we're going to need one, so I'm going to borrow one from the starter content. Let's open the content drawer, go back to the starter content folder, and let's go to materials. Notice the starter content has a lot of cool materials. Now, these are more exciting than just a flat color with metallic and specular and roughness. These are more complicated. Let's go to mbrick clay new. I'm going to double click on that. And if I use my mouse wheel to scroll out, notice this material is quite a bit more complicated. So as you can see, these material graphs can get more complicated, and there are developers who specialize in materials. So this is really a whole science in itself. Now, scrolling in on this texture sample that has blue on it, this is what a normal map looks like. If I click on this texture sample, over here in the details panel, there's a property called texture, and it links back to a texture file in the starter content folder. Now we can browse to it with the browse to icon, and here's where it is. If we double click on this texture, then we're going to open up the texture editor. So much like the material editor and the static mesh editor, there's an editor for textures. And this is what a normal map looks like. It has red, green, and blue values, and each of those values corresponds to a direction. And the direction is the direction that light should bounce off. Specifically, it's a normal vector. So as light shines on a surface, if it has a normal map, the normal map is telling the light renderer in the engine how to bounce light off of any given pixel based on these red, green, and blue values. And the result is that a flat surface can now look like it has cracks and bumps and ridges because it has normal data. We're going to add this normal texture to our mdrone material here. We can do that because we have it open in the content drawer because we browsed to it. And if you're lost here, just go back to mbrick clay new, find that texture sample. It's right here. Click on it and browse to that material. It'll be selected here. It's called tbrick clay new _n, N for normal. Now, in our mdrone material, we can open that content drawer and bring in, we can click and drag in that normal map and release. And we get a new node. It's one of those texture samples. So a texture sample node is a way for the material graph to represent a given texture. And I'd like to use this texture sample for the normal map. And I'll do that by taking the topmost pin that says RGB, that's just the red, green, blue values, and hooking it up to normal. Now let's look in our viewport. Notice that it looks like we have more geometry. We really don't. It's just that we're creating this trick where the engine bounces the light off of the surface according to the red, green, blue values in that normal map. This is a nice optimization that allows us to get what looks like a lot of detail without our mesh having lots of polygons, as that would be more expensive for the game. Let's click on Apply and go back to Basic Map, and we can see what this looks like in our world. We have this metallic looking brick object, and that normal map is of course applied to the drones as well, so we can see what it looks like there. It looks interesting, but that's not really what that drone is supposed to look like, is it? So that is the effect of the normal map. So back to our drone, we can see that changing these properties in the material can drastically change the look of any mesh that has that material applied to it. But we were really just playing around to learn about these. We're not going to use this material for our drones. We're going to use some of the textures that we have for the drone. So much like the normal map can take a texture as an input, the other channels can also take textures as well. The base color doesn't have to be one flat single value. We can have a texture or an image that is plastered across the face of the mesh, and that can determine the base color. And we can use textures for the other inputs as well. And that's what we're going to do when we construct the drone's material with the textures that we have for it in the next video. Great job, and I'll see you soon.